Good morning, everyone. I'll start in 1 second. Okay, cool. So I'm going to go ahead and just give a update on what's been happening in phase 2 from various teams, but this is from Quilt side. Slides will be on Twitter afterwards. I'll post them, WJville. And in general, I'm going to zoom through a lot of content here. This is supposed to just give a really big and quick overview. It might take a little longer than 20 minutes, 25. And the goal is to give you guys a lot of resources and links to particularly look at some of these things that you might be interested in that you hear me cover and zoom through. So I'm going to go really, really fast through a lot of more dense technical material, but find me or anyone from EWASM Quilt ETH2 research team if you have questions. So cool. So Quilt, we are part of R&D under consensus. We've been collaborating specifically around phase 2 with various teams. Teams on that have been the ETH2 research team, EWASM team, and now also TXRX, which is a new team. We're particularly focused around research around ETH2 phase 2. So really quickly, I'm just going to breeze through this 1 minute. So there was a proposal around execution environments from Vitalik that came out. The basic ideas in Ethereum, if you're reducing a bunch of transactions, it's a basic reducing function. You have state that's mutated. If you make it stateless, then it's a pure reducing function. So you have a state hash that goes to a new state hash. And the original idea behind this is somewhat evolved, but the original idea behind this is the beacon chain held different execution environments or reducing scripts that on the shards defined different account models, things like you could put ETH1 as an execution environment, UTXO model, a improved ETH1 or ETH2 account model. And this is kind of the, some of the original ideas. But engineering progress up to DevCon, some things that happened. We had built a fork of Lighthouse, which is a ETH2 client done by Sigma Prime that built a POC on phase 1. We had a basic execution environment running some WASM reducing functions as well. We had done a execution environment called Sheath, which worked on sparse Merkle tree to do transfers. And we gave an overview actually around DevCon, which gave an update on phase 2 progress. So there's a lot of dense material there. The EWASM team did a lot of research on different accumulator formats as well. So there's Turbo Token, SMTP, Merkle C token. They also did a ZK rollup demonstration as well. One of the interesting things is the C Merkle token showed to have promising performance. Some of the others were slow. Turbo token showed to also have some promising performance as well in the initial prototypes. And then there was also work around WASM basically adding host functionality into the system to allow for WASM to call into other WASM scripts. This is similar to the call or delegate call opcode in ETH. And then just a number of other experiments, sample repos, there's Quilt repos, and then also you can look at eWASM repos. There's a bunch of different cool things that were added. So at DevCon, some things that kind of came up and were realized is EE communication was fairly difficult. So for EEs to send each other ETH, as an example, you would need to go through the beacon chain. And this, adds load to the beacon chain was fairly slow. Cross-shard communication would take an entire epoch. 6 minutes also seemed a bit slow. And building the ETH1 execution environment seemed to be a bigger effort than we originally foresaw. There were also other ways at the time that we had looked at possibly speeding up that cross-shard communication. So we kind of looked at this optimistic system with dependency graphs that could roll back. You could prune off the different branches of the graph, different things like that. This seemed to have some complexity involved, some state issues, some other things. And then there was also some questions around significant centralization, censorship risks in the relay market design. So actually linked to research posts on all these that reference this. So results from DevCon, Vitalik actually released a new proposal at the end of DevCon that it's the reduction of shards proposal I linked to here, and it brought a number of interesting benefits and solved some of these problems. So one of them is it reduced the cross-shard communication to one beacon slot, so 12 seconds. It opened up a good path to reduce some of the censorship issues that we saw from relayers and the relayer design that we had before. And it also seemed to start simplifying some of the ways we might communicate between EEs. In that paper, there's a whole section which talks about the operating system. And so this was the beginning of thinking about moving ETH balances onto shards. And so this opened up a whole new set of discussions. So after DevCon, I wouldn't say it was officially delayed or pushed forward, but there was another proposal that was pushed forward. Instead of building an ETH1 execution environment, it was instead moving ETH1 into the POS, the proof of stake world of ETH2, and reserving a shard, particularly for ETH1 to run on. And so in this world, ETH1 would need to go stateless. And if you wanted to be a block proposer on the ETH1 shard, you would sign up as having special capabilities, and you would therefore be running a ETH1 client. And so then around this time, the ETH1X group had formed, stateless group, and set up a roadmap to begin to work on witness aggregation, collection, propagation, as we transform ETH1 to make it stateless and performant, and also update the various tree formats that are used. Initial results seem quite positive, and they've been giving a lot of updates and been quite productive. So continued research into the new year. So one of the things that we found was in the ETH2 world, we had some issues that had to do with the state provider network, getting witnesses to your transactions that the ETH1X effort wasn't having to look at right away. And this was in particular, the constraint here was in ETH1 miners hold state. So when they get transactions, they can attach the witnesses, attach the proofs that they need in a stateless world. But in ETH2, miners or block producers and validators are not assumed to have state. So this somewhat added complexity to the model. And so as a result, I actually released a research paper that talked about some of the remaining questions, and then Ansgar and Sam, I think Ansgar and Sam are here. Yep, Ansgar, Sam, released a really good write-up around static state access, dynamic state access, and different state provider models. So definitely encourage people to look through this and look through some of the links around this. So we kind of came to 3 recommended models. One we call the direct push, the relayed push, and the pull. And to give, again, giving an overview here, I'm not going to go into too much depth, but to give a quick overview, the direct push model seemed to be, this slide went out. Cool. I don't know if I touched one of the cables. The abandoned ship. Okay. It looks like it's the screen or the setup here. Technical difficulties. No, it's still going in and out. I tried disconnecting, reconnecting as well. I could tell a joke. No. I don't know any. Otherwise I would. Joke. Robert, you know good jokes. I recommend you. What's that? 20-minute joke. Oh, yeah. Yeah, it doesn't look like the connector. It looks like it's cycling through trying to find the setting. Yeah, it's not the connector. Yeah. Definitely not. Yeah. Maybe you can take questions. Yeah, I could take questions. I could just talk without slides as well. That's helpful. But any questions in the meantime while we fix this? So at East London, there's a question that was supposed to be when I was talking about. And there's something that I used to point out that hello. From their perspective, having new state providers in the system was very scary. That was the exact word, repeated many times, even as I would kind of talk about, how it's a network and people can join and other things. What are your takes on, are state providers scary or are they a good thing? I think they're a good thing. I think they're interesting. I think we're taking there's a first step diving into this in a production environment with the ETH1X work and moving that into a stateless format. So I think we're going to get a very early view into that. Is that connecting? Yeah, so I think we'll get an early view into that. I think from an ETH2 perspective, I generally think it makes sense. It's a good way to kind of partition the state amongst different parties in the network. And generally seems like a good pattern for that. Doesn't tie the entire global state to just one shard. You can have different parties that are holding different parts of the state on a shard or on multiple different shards, as an example.
Yeah, that's makes sense. I mean, I think the where that sort of fear came from was the fear that state providers would somehow introduce a new centralization attack vector, for censorship and so forth.
Yeah, I think one of the ideas is if you can always sync to the chain and look at the witnesses that were formed, you can kind of reconstruct the state that you're interested in. Mm-hmm. So there's that. Yeah, that's a really good point.
Becoming a state provider is like becoming a full node today. You basically just have to sync the state, and then you're a state provider. So
yeah.
But if we achieve scaling, isn't it necessarily harder, right? Because you have so much more state. So, for example, if we 2x the throughput, then it's twice as hard to provide the full state. So it's to say it's just like being a full node now. That's I run full nodes. It's difficult. It's not easy.
Yeah, I think what's interesting there is it depends what state you want to form. So if you're a user and you're particularly wanting to use, one particular application, you can kind of track the state associated with that, the witnesses that were uploaded.
Yeah, and that goes to my actual question, not just snarky Carmen's. Has there been any consideration for how users will store state locally that they're interested in?
I think different, basically, if you have a different wallet provider that you might work with, there could be options, one, to store parts of that state in your local storage, but that can't be like a reliable long-term method because that can always be lost or cleared. But it seems like a good way to be able to cache that for yourself, as an example. But yeah.
And last question. And then has there been any looking into how that model is similar to the watchtower model from a payment channel or a state channel?
So I would say it's a bit different because the watchtower model, you basically have someone out there making sure funds aren't being stolen from you. In this case, it's not like the witness just disappears.
They have the commitment. Right? You submit a commitment to them, and then they're obligated to hold that commitment. And in this case, instead of them holding the commitment, they would hold whatever state you pushed up to them.
So my understanding, so there might be some similarities or some analogs. My understanding, the watchtower general issue, correct me if I'm wrong, has to do with the fact that when you have various exit games and periods of time, you need to make sure someone's watching your state to make sure that someone's not trying to exit with something that you hold claim to. So I think that's been my general understanding of that.
Yeah, the similar problem with synchronization of the app, right? So if you're offline and you have paid someone to track an app for you, they're not, they could be potentially making sure funds aren't stolen, or it's equivalent.
Yeah, so I think in general, again, it depends on the construction that you have, but if there's a double spend or something like that, that would be a consensus issue. And so you imagine that there are any n number of nodes that are following that particular shard and can see that that's a consensus issue. And I believe there's a few additional security guarantees coming in the protocol as well, which would be fraud proofs at some point. But yeah,
Thanks.
cool. Sure. Maybe this screen will start working.
When I would do a transaction, who's responsible for submitting the state to every verifier?
So this was about what I was about to talk about with the diagrams. So there's these three models. And so there's the direct push, relayed push and pull. I had some pretty cool diagrams to go with it. The one that we recommend that seems to provide the most simplicity in design is the direct push model. And in particular, in the direct push model, the user is responsible for their witness generally. And so when I have a transaction that I need to sign, I would reach out to some party, a state provider, or if I own my own state, then that's fine. I can use that. Transaction. And so if the transaction tries to touch a particular piece of state that I don't point out in this access list, then I'm attributed to that fault as a user. And so that's the direct push model. The other models that we've had are pull model and relayed push. The pulled model in particular puts the burden on the block producer. So the block producer gets a bunch of transactions, and then it's up to them to find some type of state provider to then bundle and attach the witnesses for them. There's some complexity there because they need to understand how to order that properly. So we generally recommend this direct push model. One of the things that the direct push model would require that's different than ETH1 is ETH1 follows this pattern called dynamic state access. Basically a good example of this is when you can't deterministically say which state access location you're going to touch. So a simple example might be you don't know what the next block hash is going to be. So if you have some type of transaction that is dependent on what that block hash is going to be, and based on that block hash, it may access a different part of state, that would be an example of dynamic state access. And so one of the things that in this direct push model, which seems to, produce a much simpler system that we've looked at is changing this, and we're not set on this term, changing this to what we call static state access. Predictable state access, OnSCAR likes, there's a few other terms. And so this goes along with an access list, and this means you can't dynamically touch state. But through our research that we've shown that actually upgrading existing contracts. So we started off with IDEX and Uniswap, so two on-chain DEXs. Making the updates to SSA looks like there would not be that many changes. We need to continue to look at research for other sets of contracts like Maker, things that are a little bit more complex. But it does seem like all the patterns that we have today, we could continue on. They may just require some different developer patterns. And so one of the things that we did to look into that as well is Sam actually extended the Solidity compiler into Yule to do what we call taint analysis. And what this does is it actually looks through the code that you might write in Solidity to make sure that you're not using dynamic state access patterns. That way, there can be some developer tooling to let you know if you are using these patterns, as an example. And so, yeah, that was a really, really long answer. But I was going to cover this really cool pictures, but if you guys just came into the room, like 1/3 through my presentation, the screen's not working, so I'm just doing Q&A now. So if you have any phase 2 questions, feel free. And like all of us are answering, so.
How many different execution environments do you see, say, like, at first and then like over time? What do you see as like a upper bound or?
Yeah, so I wrote an ETH research post recently, which was a way forward. I forget the title, a way forward with phase 2. It was kind of the culmination of a lot of, I guess, our work talking with some of the other teams that are working on phase 2 as well. And the general direction is that we want to support, so we want to make decisions that look forward to this world where there might be multiple execution environments. So things like a direct push model, right? Things like having static state access, other decisions that seem to be decisions that give us longevity. But starting off by really focusing on one main execution environment as a design, trying to make that really strong. And then once we get that in place, then we want to continue to play with more execution environments. And so one of the trickiest things, and I was going to talk about this as well, when we look at how execution environments fit into this as a whole, is how do they communicate with each other properly? And actually, it seems that if we move forward on static state access or predictable state access, it makes that communication drastically simpler and could reduce scope. And there's some really cool things. So it seems, again, never want to deterministically say something, but it seems from our early research that execution environments would be able to call into each other directly on the same shard synchronously. Whether that's a pattern we want or we don't want, I'm not sure, but it seems like a pretty interesting feature. One of the reasons why I think this is interesting is it can help with a good migration path. So if you're, want to upgrade to a new accumulator format, a new, governance model, rent format, whatever else, you can launch that, and old contracts would be able to, from old execution environments, interact with new contracts from older execution environments, if it works out in this way. And there could be even interesting ways where contracts could have their own governance, and they could upgrade themselves into a different execution environment as well. But that being said, we realize, as far as scope, it's good to focus on one for now, get that really solid, and then expand the domain while still making decisions that give us longevity. So,
cool. Thanks.
Yeah. Any other questions?
Keep asking questions.
Nice. And anyone else's, like Vitalik, Sam, anyone can answer questions too. But yeah.
Hi.
Matt.
What is actually the most recent or most up-to-date source to if one wants to dig into the topic and does some reading, or what you would recommend looking into the code from your? For example, at the moment I'm at your simulation on GitHub. Would this be a good entry point? So what is the best entry point for reading?
So best education entry point for reading, I think go through that ETH research post, and that links to pretty much everything. So that's the way forward and path
your
forward.
last post you did was wrapping up stuff.
Yeah, I gave a history as well. I think that could be helpful. I think also Proto has a work in progress spec for phase 2 as well, which is really cool. And yeah, so I think both of those would be good starting points, and then those can kind of take you down the rabbit hole.
Okay. Is this simulation repo already executable or testable?
Yeah, so that's in progress. There's a PR that's going to be merged in soon. But yeah, as of now, you can run basic execution scripts on it. Cool. We've had various iterations of that too. So as I said, at one point we had a fork of Lighthouse that did this. One of the reasons we moved out of the fork of Lighthouse is just how rapidly changing the phase 1 and phase 0 spec were. And so it's going to be hard, and also how quickly they move. So it's hard to, rebase all these changes in versus just abstract a lot of those pieces. And so that was the motivation for moving towards this simulation repo. So yeah. Other questions?
Isn't SSA just required to sort of, isn't it sort of just like isn't just like broadly speaking an improvement over the existing EVM model? And is there any interest in just applying that to ETH1 as a technique?
So it'd be interesting to apply that to ETH1. There'd have to be like a slow migration pattern because contracts right now use SSA in general. So you could say 5 years from now, SSA transactions will no longer, like now you have to use access lists for ETH1 as an example. So, but I don't think you could just turn it off right away. I don't know. Do you have an alternate opinion?
So right now, contracts in ETH1 are built using dynamic state access. It's not something that's been considered when writing contracts. And SSA is taking away a feature from the perspective of dApp developers. So contracts that currently run wouldn't be able to run anymore. So as Will was saying, you'd have to slowly migrate over. Contracts would have to be rewritten, and then there'd be a date at which you could remove DSA from ETH1. But I think the timeline you'd have to do that on is probably in line with waiting for ETH2 anyways. So I don't think there's that much point in doing it. But that's just my opinion.
Thank you. I had another question related to that. Oh yeah, couldn't it just be like, aren't those, how many, I don't quite understand exactly what qualifies as DSA. So I don't know how difficult it would be to restrict that within Solidity, right? Like if you upgraded Solidity, like what functions would a developer lose?
So if you stick around for the next presentation in here, I have a small talk about some work I've been doing in the Solidity compiler. But it's not impossible to detect DSA in Solidity, but it is everywhere because no one's been paying attention for it. So you can't just port contracts without modification. So if you want to know more, stick around.
Cool,
I'll be giving some info later.
Yeah. Also, sorry, you were asking the different repos. Playing around with C, I think Ewasm RT that's in there, which is a wrapper around Scout. I'm forgetting what's the name, Matt. Johnny Ease. I think might be better entry points. Those plug in. Those will ultimately plug into simulation. But yeah. Cool. Sheath is an old, interesting one, but I feel like it's easy to read. Good job, Matthew Garnett. Yeah. So one thing that's interesting, so something that Quilt is particularly doing, we're shifting our focus. So we've been fairly research heavy over the last few months, just because there were blocking research questions that we had. But most of those blockers are out of the way. So there's still many research questions as we implement. But we're shifting more towards an implementation heavy approach at this point. So we're kind of evolving into a new stage now, which is cool. It's just kind of cool to see the progression from all these research questions. And now we have, a good roadmap and plan forward, which is sweet. I don't know. I wish I could have given you guys the full presentation, but hopefully the Q&A was helpful. And maybe, looks like the screen's still not working. So good luck. GG on the next presentations in here. I think that's Xiaowei. That being said, I could take more questions unless I want to transition this over to Proto and Xiaowei. Sounds good. I'll keep taking questions. Any other questions? All your phase 2 questions. let's see. I'm going to go through my slides and see if there was anything. 'Cause the questions were good. You guys actually covered a lot of the points. It's just I had like really, really good cool pictures and diagrams. I spent a lot of time on and links. Like I said, I'll post these on my Twitter. So it's WJVILL. And there's a ton of links. Most of them, like, yeah, a lot of GitHub and ETH research links in general. Yeah.
I've more general question here.
Yeah.
I'm wondering what's the long-term benefit of having multiple different types of execution environments?
Ooh. Sorry, long-term benefit of what?
Of different types of execution environments.
So the thing that I think is interesting about this space is, so in the post that I put up, I put like a bunch of different points. But one of the ones that I think is interesting is if we want to, for example, we find a new accumulator format that we want to use, or we want to use a completely different account model, or we want to introduce some type of UTXO format onto this, like, core light protocol layer. What's cool about this world of execution environments is you can do that with minimal overhead. This is
Of this room that have access to a really strong crypto economic consensus system, and then have total freedom at execution layer to do whatever they want. Some people would say, well, you kind of have that with ETH1 already. You can create an ORU that does whatever you want as well for execution systems. But ETH2 provides a really nice difference from that, because in ORUs, you do have to have some kind of exit game and so forth in order to give it security, unless you have all the data available on chain. And
Okay. Cayman, do you want to diagram something? Mehdi, give us a sigma prime update.
Well, I'll be giving a talk on Lighthouse on Thursday afternoon, so you guys are welcome to come to
Sweet.
that. But yeah, we've been busy.
Ansgar, you can talk about the Uniswap updates you did. Uniswap updates you did. Yes. Maybe that's interesting.
Yeah, hi everyone. I'm Ansgar. Just so basically, part of the SSA feasibility study that we did was look at few popular contracts and see how well you could port them to SSA, and Uniswap was the first one. So, so right now our impression is that actually all major projects right now live on Ethereum could just work on the SSA as well. But specifically for Uniswap, because it's really just like two contracts, we basically more or less wrote a SSA version of that, and so that really would work without any issues, and so that's encouraging to see. So that's why we actually are rather comfortable going down the SSA road. Yeah, that's that.
Hi. If I am new to Ethereum and I really want to do ETH2 work, how do I go about doing that? What's like the best way to jump in?
Ooh, what part are you most interested in? It's such a huge design space, right? Curious. So we're actually working on we should release it soon. We've been working on a book, that makes the ETH2 landscape accessible. Starts off by covering Phase 0 in a lot of month or so. So I think that would end up being a good resource, but that's not there yet. I think reading through the specs is interesting. I don't know, do people have other recommendations? The Ethereum 2 specs, Vitalik?
I also wrote this document called the Serenity Research Compendium that I update once every couple of months. I think if you just search those words on your favorite search engine, you'll find it pretty easily. What is it? Serenity Research Compendium.
And I think more and more resources are going to be coming out, so that should be helpful. Any cool things you want to talk about, Proto?
There's always more and more things to talk about, except that we don't have a working screen yet. So we can try and do more questions, or I could try and give my talk without slides, which would be exciting, though not as helpful. And yeah, we don't just hope the screen can get working. One more question.
Move away. Okay, you can, since there are no technical questions about the ETH phases that have been asked, I'm interested in if we have, it's early, it just happened yesterday, but do we have any learning
That's okay. Move the far wheel here. All good now. Okay. Does everyone see the whiteboard? Who here thinks the face is happy? This face. Who here thinks that face is sad? Okay, that's good enough. So, what I wanted to go through is kind of specifically ETH1X to ETH2 kind of transition roadmap, and in particular, kind of what the merge will look like, right? So, just as a quick background, kind of the current. So for the ETH2 roadmap, we